What you're looking at is a very simple alternating current or AC generator, a device that converts mechanical energy into electrical energy. This part is called the armature. It's made from metal and electricity is generated by its rotation between two magnets. To show clearly how the generator works, one half has been coloured yellow. The armature can be rotated in various ways, for example using pressurized steam, as in a power plant, a flow of water from a dam, or a flow of air from a wind turbine. These parts are called slip rings. They are also made of metal and are connected to the armature. The slip rings and the armature rotate together. The rings are connected to brushes made from carbon. The brushes make contact with the rings as the rings rotate, so they provide an electron flow within the system. In order to determine the magnitude and direction of current, a galvanometer is attached. When the armature starts to rotate, an electric current is formed. This is because the magnetic flux changes over time. Magnetic flux is a measurement of the total magnetic field that passes through a surface. Notice that electric current is formed not because of the magnetic flux, but because of a change of flux. Magnetic flux might be non-zero, but if the rate of change of the flux is zero, there won't be a current. Formation of electric current depends on the change of flux, which can be calculated by this formula. If the angle between the area vector and the magnetic field is zero, the rate of change of the flux is zero. When the armature is parallel to the magnets, the rate of change of flux is zero, so that no electricity is generated. But as the armature rotates, the magnetic flux starts to change. Electrons in the armature start to flow, and an electric current is formed. After a quarter of a cycle, the change of the magnetic flux reaches a maximum, and so the current reaches a maximum too. As the armature continues to rotate, the change of the magnetic flux gradually decreases, and consequently the current decreases as well. When the yellow armature part reaches the bottom, the armature is parallel to the magnets, and because the change of magnetic flux is zero at this point, the current is zero as well. Up to this stage, according to Fleming's right-hand rule, the current's direction is inward. As the armature keeps rotating, the magnetic flux starts to change again and reaches its maximum when the yellow armature part approaches the magnet. As the armature rotates further, the change of the magnetic flux decreases until it becomes zero and the cycle is completed. Between half and complete cycle, Fleming's right-hand rule indicates that the direction of current is outward. So every quarter cycle, the electric current reaches a maximum, and every half cycle, the current drops to zero. After every half cycle, the direction of the current changes. This change of the direction of the current is the biggest difference between alternating current and direct current. In direct current, in order to prevent changes of current direction, only one ring, known as a split ring, is used. In an AC generator, the frequency at which the current changes direction is determined by the rotation speed. For example, in the United States, the AC frequency is 60 Hz, which means that the current changes 60 times back and forth every second, whereas in Europe, the AC frequency is 50 Hz. The choice of these frequencies dates back to the 19th century. At this time, efficient speeds for steam turbines to rotate were between 3,000 and 4,000 revolutions per minute. In Europe, 3,000 RPM generators began to be used, which generate 50 Hz frequencies, whereas in the US, 3,600 RPM generators were used, which generate a frequency of 60 Hz.